Hello everyone, welcome to my YouTube channel. Today we will see the topic from Engineering Mathematics 3 Fourier transform. In this lecture, we see the Fourier transform for even and odd function. First we see for even function. For even function in minus infinity to infinity, Fourier transform is given by f of lambda is equal to integration from 0 to infinity f of u cos lambda u du. And the inverse Fourier transform is f of x is equal to 2 upon pi integration from 0 to infinity f of lambda cos lambda x into d lambda. Remember this, in Fourier transform we denote this by f of lambda and we find the integration with respect to du. In inverse Fourier transform, we find the value of f of x. For this, we integrate with respect to lambda. Similarly, for odd function. For odd function in minus infinity to infinity, Fourier transform is given by f of lambda is equal to integration from 0 to infinity f of u sin lambda u du. And the inverse Fourier transform is f of x is equal to 2 upon pi integration 0 to infinity f of lambda sin lambda x d lambda. Here, this Fourier transform for even and odd function is same as the Fourier cosine transform and the Fourier sine transform. Only the difference between these two is here the function is defined in the interval minus infinity to infinity, and in sine and cosine transform function is defined from 0 to infinity. Now we will see the examples of these even and odd functions. We see the first example. Find the Fourier transform of f of x is equal to, here function f of x is defined as the value of function is 1 if mod x is less than a and value is 0 if mod x is greater than a. First we see the figure for this. Here we draw the figure. We write the function x, variable x on x-axis, and the function f of x is on y-axis. Now the value of function in mod of x less than a is 1. Mod x is less than 1, less than a, that is the value of x lies between minus a to a. If the value in minus a to a is 1, then we draw the line. Value of function f of x is 1, that is this line in between minus a to a. This is parallel to x-axis. And otherwise, that is if mod x is greater than a, that is if x is less than minus a and x is greater than a, then the value of function is 0. Therefore, otherwise the value of function is 0. Therefore, we draw the figure. We connect minus a and a. Now we check this function is even or odd. For checking function is even or odd, for this we replace in function f of x by minus x. If we replace f of x by minus x, we got f of minus x is equal to 1. Here mod of minus x is less than a and value is 0 if mod of minus x is greater than a. Here value of mod of minus x is again mod x. That is, if we find the value of f of minus x, then again we got the same function. Therefore, the given function is even function in the interval minus infinity to infinity. If the function is even function, then we find the Fourier transform by using the formula. We have Fourier transform f of lambda is equal to integration 0 to infinity f of u cos lambda u du. Now we put the values here 0 to infinity. We take 0 to a and a to infinity. But in between a to infinity, the value of function is 0. Therefore, we take only 0 to a. Value of function f of u in 0 to a is 1. Therefore, 1 into cos lambda u du. Now, we find the value of integration of cos lambda u. The value of cos lambda u is sin lambda u upon lambda. We put the limits from 0 to a. If we put the upper limit a, then we got sin of a lambda upon lambda. If we put the 0, value of sin 0 is 0. Therefore, we got the value of f of lambda is equal to sin a lambda upon lambda. And this is the value of Fourier transform for the given function, which is the even function. Similarly, we find for the next. Same example, only the change in the value. Find the Fourier transform of f of x, where f of x having the value minus 3 if mod x is less than 1 and value of function is 0 if mod x is greater than 1. Hence, evaluate the value of integration from 0 to infinity sin lambda cos lambda x upon lambda into d lambda. We deduce from all of these integration of 0 to infinity sin lambda upon lambda into d lambda. Now, first we find the value of Fourier transform for the function f of x. For this, we use the same procedure as the last example, and from the result, we find the value of integration. For this, we use the definition of Fourier sine transform, cosine transform, that is Fourier transform for even and odd function. We see the solution. First we see the Fourier transform. Again here the given function is f of x is equal to minus 3 if mod x is less than 1. Mod x is less than 1, that is the value of x lies between minus 1 to 1. Then the value of function is minus 3. Here minus 3, this is in opposite side, that is in the downward direction. Minus 3, if the value x lies between minus 1 to 1, then we write here, draw your graph. Value of function in minus 1 to 1 is minus 3 and otherwise the value of function is 0. Now again we check this is even or odd function. Again if we replace x by minus x, again we got the same function, that is f of x is equal to f of minus x. Therefore the given function is even function, and if even function, then the given Fourier transform is given by f of lambda is equal to integration 0 to infinity f of u cos lambda u d. We put the value of function f of u in between 0 to 1. Here if we take 1 to infinity, then the value of function is 0. If we put the value in 0 to 1, value is minus 3. Therefore integration 0 to 1, function is minus 3 into cos lambda u du. Again find the integration of cos lambda u. Here minus 3 is constant, we take outside. Integration of cos lambda u is sin lambda u upon lambda. Put limits from 0 to 1. If we put 1, then we got sin lambda upon lambda. If we put 0, then we got sin 0 is 0. Therefore, we got the value of f of lambda is equal to minus 3 sin lambda upon lambda. This is the Fourier transform for the given function. Now, for finding the value of integration, we use the inverse Fourier transform. Here we use the Fourier transform for even function, we write the inverse Fourier transform for the even function, that is f of x is equal to 2 upon pi integration 0 to infinity f of lambda cos lambda x d lambda. Here we find the value of f of lambda, therefore substitute the value of f of lambda in the integration. Therefore you got 2 upon pi integral 0 to infinity value of f of lambda is minus 3 into sine lambda upon lambda cos lambda x d lambda. Now we find the value of function with respect to lambda. But here we want only the value of integration 0 to infinity sine lambda cos lambda x upon lambda d lambda. Therefore, for simplification, we write these minus 6 upon pi on the LHS side. Therefore, you got the value of integration is minus pi upon 6 into f of x. Now we put the value of function f of x. Here value of function is 3 minus 3 if mod x is less than 1. Therefore, minus 3 into pi by 6 minus pi by 6 we got pi by 2. Therefore, value of integration is pi by 2 if mod x is less than 1 and value is 0 if mod x is greater than 1. This shows the second result. Now we find the third. We find the value of integration from 0 to infinity sine lambda upon lambda into d lambda. For this, we put in this integration 0 to infinity sine lambda into cos lambda x upon lambda d lambda, we put x is equal to 0. If we put x equal to 0, then we got cos 0 is 1. Then we got the value of integration from 0 to infinity sine lambda upon lambda into d lambda. If we put the value of x0 on LHS side, also we put on RHS side. If we put on RHS side, then we got here x lies between minus 1 to 1. In this we get x equal to 0. Therefore, if x is in minus 1 to 1, then we got pi by 2. And x equal to 0 lies in this interval minus 1 to 1. Therefore, we got the value of function is pi by 2. In this way, we find the value of Fourier transform for even and odd function by using the formula. Thank you for watching my video.